So let's start with alcohols, phenols, and ethers. So this is our chapter of class 12 chemistry, and let's start with the preparation of alcohols. Okay, the first method is from alkenes. Okay, so here there are a few important ones, okay, like acid catalyzed hydration and hydroboration oxidation. Okay, these two are important ones. Of course others are also important, but then in these two hydroboration oxidation is important. And for this, that is acid catalyzed hydration, it is important for its mechanism. Okay, so coming to from alkenes, that is acid catalyzed hydration. Okay, so let's break down the words first. See, what is that? Acid. Okay, we need an acid means we need an H plus, right? If I say base, OH minus, right? Here what it is? Acid. Acid, H plus, okay. Catalyzed means catalyzed by an acid, okay. Means the acid should be written on the arrow. Okay, here I have a reversible arrow. Hydration. Hydration means what? Addition of water. That's all. Done. Which means C double bond, C bond should be added. Water should be added to it, and it should be catalyzed with an acid, means H plus ion. So what I'll get C, this double bond will be broken, and one side I will add H, other side I will add OH. As simple as that. Now here, let's take an example for this, right? Yeah, so the example, yeah, I have taken over here the example, which is, let me write it. Yeah, the example taken over here is CH3. Okay, CH3, CH, double bond, CH2. Okay, now here, what is happening? See, this is my double bond, right? And again, if I add water and then if I add that catalyzation of acid, so what will happen? Similarly, my double bond will be broken, right? And one side I have to add OH minus, other side I have to add H plus. So which side to add it, right? So the question goes like that. So the carbon having less number of hydrogen atoms, there you should add OH minus, and carbon with more number of hydrogen atoms, add H plus. So this is Markovnikov's rule. Okay, so the negative part, okay, now the negative ion should be added to carbon having less number of hydrogens. Okay, now what is the mechanism for this reaction? Okay, this mechanism is important. So firstly we'll break down an acid, let's say H2SO4, right? Breaking down into its ions, okay, 2H plus SO4 minus. Okay, so this further taking one H plus from here, adding it to water, right? We are having water here, right? We need acid also, we need water also for hydration. Adding this H plus into water, we will get an ion like this, H3O plus, hydronium ion, right? So then the step one is formation of carbocation. Okay, so this is my alkene. Okay, adding this hydronium ion, what I'll do here, in the first step what will happen is, this hydronium ion I am adding to this alkene, right? So this double bond would be broken, okay, and one hydrogen will be added to this. So what will I get? See, bond is broken but nothing is added to the middle carbon, right? So it will just stay like that with the positive charge. Okay, so I will have this carbocation with me. Okay, carbon chain or carbon with positive charge is known as a carbocation, right? So carbon chain with positive charge plus H2O as usual, right? Then we have formation of protonated alcohol. Means what? See, one hint is that whatever is your, okay, result over here, that will be the reactant over here. Whatever is the product in the previous one will be the product in, will be the reactant in the next one. Product in previous, reacted in the next. So I will take the same carbocation, okay, and reacting it with water. Okay, the same thing. See, this same thing, right? These two come and become the reactants. Now what will happen? This is a reversible reaction taking place. Now oxygen has lone pair of electrons, right? So using this lone pair of electrons, it can form a bond with carbon. Okay, carbon's valency is done. 4, right? One with H, one with this C, one with this C, and one with this O. Okay, but still what happened here, this oxygen gave its electrons to form a bond, right? So it will have plus charge over here, right? The plus charge from carbon will shift to oxygen, and we will get a something like this structure. Okay, protonated alcohol, this is called protonated alcohol. It is super important to put plus signs or the charges. Okay, mark the charges everywhere. It is just super important. Okay, because to show protonated alcohol we have to show O plus, right? And then what we will do, using this same thing, deprotonation to get alcohol. Okay, reacting this same thing with H2O. Okay, reacting this same thing with H2O, we will get a protonated alcohol. Okay, plus the same thing that we gave before, hydronium ion. Okay, yeah. So this was the mechanism from alkenes when we talk about the preparation of alcohols. Okay, now the second important, very very important method, of course this is also from alkenes, but hydroboration oxidation, HBO, right? Then here of course I'm taking the a simple straight example, that is CH3 CH2. Okay, so this is an alkene, right? Propene plus HBH2 twice. This is called diborane. HBH2 twice, or simply BH3 twice also you can write, right? Three hydrogens are there. So inside the bracket three hydrogens, and outside it is twice. Okay, we should remember. And when I react this alkene with this diborane, what will I get? See what is happening. See here, when I react this with diborane, again my one bond is broken over here. Okay, carbon having, okay, this is CH, which has less number of hydrogens. I'm attaching H over here and BH2 over here. Okay, now what will happen? Now again, what is happening? See, very very important. See, in previous method, that is acid catalyzed hydration, we learnt about Markovnikov's rule, right? That the positive negative part should be attached to less carbon having less hydrogen atoms. Negative part, that is OH minus, should be attached to the carbon having less number of hydrogens. But in hydroboration oxidation the process is ulta. We are following anti Markovnikov's rule. What is anti Markovnikov's rule? It says ulta, that the positive part should be attached to the carbon having less number of hydrogens. So that is the case over here. That is the biggest difference between the two. Okay, so then coming to, okay, I have attached these two. Again I react this compound with one more alkene. What I will get here, I'll get CH3 CH2 CH2 twice BH. So slowly these alkene groups are replacing this H, okay, present in BH2. Okay, the first H gone out of BH2, only BH is remaining now. One more alkene if we add, the last H also gone from BH2, and from BH it's H gone, and okay, now no H's are left with B, right? And it is only left with CH3 CH2 CH2 thrice B. Okay, now this on reaction with 3H2O2 and OH minus ion and water, it will give us 3 moles of CH3 CH2 CH2OH plus BOH thrice. And what is this CH3 CH2 CH2OH? Okay, that is our alcohol, right? Propanol. Okay, that is our alcohol. 3 carbon alcohol propanol. Then coming to the second method, from carbonyl compounds. Okay, reduction of aldehydes and ketones. First method in this is reduction of aldehydes and ketones. Okay, this is my aldehyde RCHO plus H2 giving PD. In presence of palladium, it will give us primary alcohol, that is RCH2OH. Okay, aldehyde plus hydrogen in presence of palladium will give us a primary alcohol. Ketone in presence of a reducing agent like NaBH4 will give us a secondary alcohol, that is RCHOH R dash, or it may be a symmetrical one also where both the R's are same, right? Or both the R's can be different as well. Now coming to the second method under carbonyl compounds, that is from carboxylic acids and esters. Okay, so this RCOOH, that is carboxylic acid, on reduction with LiAlH4 and the second step H2O, it will give us RCH2OH. Okay, RCH2OH. Now commercially what happens, this RCOOH on reaction with another alcohol, that is R dash OH, and acidification H plus will give us RCOOR dash, which is an ester. Okay, so this ester on reaction with H2 and a catalyst, okay, in presence of a catalyst, will give us R dash OH, the same alcohol that we initially, attached with it, or we initially put, and one alcohol, that is RCH2OH. Okay, now coming to from Grignard reagents. Okay, now this RMGX is known as Grignard reagent, right? It is known as Grignard reagent. Now this reagent on reaction with HCHO, which is formaldehyde. So this is super important, these three equations. First one, when the Grignard reagent reacts with formaldehyde, only in the case of formaldehyde this happens, that we will get RCH2OMgX, and this on reaction with water will give us primary alcohol, that is RCH2OH. Now again, if I have an Grignard reagent, okay, to give an alcohol, if we need, okay, one more Grignard reagent like R dash MgX, okay. So this R dash MgX, I am reacting with RCHO, okay, which is an aldehyde, right? Which is an aldehyde. So what is happening? See, we got CHRROMgX. Again, you can see we are left with only one hydrogen, right? Only one hydrogen is there, right, in RCHO. So what is happening? RCHO, this R remains the same. Only this R and MgX get attached to carbon. Okay. So here R, it becomes CHRR dash, and with this O attaches MgX. Okay, this on reaction with water gives RCHR dash OH, which is a secondary alcohol, plus MgOHX. Okay, in all the cases we have plus MgOHX. Okay, then if we react this same Grignard reagent R dash MgX with RCOR, which is a ketone, it will give us, see, three like this R. Okay, we have C R3, or they are, if they are different, then here we have R dash, here we have R, here we have R, and to that O it is attached MgX. Okay, MgX is attached again on reaction with water, it will give us a tertiary alcohol over here, right? Okay, R3COH. Okay, these are the different alkyl groups. Now coming to from diazonium salts, the third one. Okay, yeah, before that, diazonium is the preparation of phenol, right? So these were the only three preparation methods of alcohols. Okay, so the first one was from alkenes, wherein we discussed about acid catalyzed hydration, right, and hydroboration oxidation. And the second one was from carbonyl compounds, in which we decided again two discussed again two, right? That is from reduction of aldehydes and ketones and the reduction of carboxylic acids and esters. Next, we discussed from Grignard's reagent. Right now, coming to the preparation of phenols. Okay. Now, when we talk about phenol, what is the phenol actually? What is a phenol? It is just a benzene ring with OH group. Okay. So, phenol, when we talk about preparation from haloarenes. Okay. So, haloarenes means what? This is a chlorobenzene, right? Benzene with any halogen like chlorine, fluorine, bromine, iodine, right? So, this is chlorobenzene plus NaOH in presence of 623 Kelvin temperature and 300 atm pressure. It will give us a compound called sodium phenoxide. Okay, now this sodium phenoxide will give us phenol. Okay, now how will this give us phenol? When we react it with HCl. Okay, I'll just add it. When we react this with HCl. Okay, yeah, when we react this sodium phenoxide with HCl, then this Na and Cl will go off. We will be left with only phenol group. Okay. Then next, coming to from benzene sulfonic acid. Okay. Now this is benzene with which we react oleum. Now what is that oleum? It is H2S2O7. Okay. Let me write it down. Yeah. It is H2S2O7. Okay, now Yeah, so this benzene sulfonic acid that we get when we react it with NaOH in the first step, second step acidification or reaction with H plus ion, we get OH. Okay, phenol. We get OH attached to the benzene ring, which is our phenol. Okay. Yeah. Now coming to the third one, that is from diazonium salts. Yeah. So from diazonium salts, as in first we need to create the diazonium salt, of course. So first we have aniline, okay, benzene ring with NH2 that reacts with NaNO2 and HCl to give benzene diazonium chloride. That is benzene ring with N2Cl, wherein N2 plus and Cl minus. Okay. So this is a salt. Now, when this reacts with H2O and warm, okay, then we will get a phenol plus N2 plus HCl plus N2 plus HCl. Now, coming to decarboxylation of salicylic acid, okay, super important. Let me, okay, just make them a tick. Okay, so it is super important, decarboxylation of salicylic acid. So this is my salicylic acid. It is just a phenol ring attached with a COOH group. Okay, this is salicylic acid. Now this, when we react with NaOH and CaO, that is calcium oxide, in presence of heat we will get phenol. Okay, then the next method is from cumene. Okay, this is also a super important process. Okay, now let me zoom in for that. Okay, for cumene, if I come, see, this is my benzene ring. Okay, benzene ring plus this CH3, CH2, CH2, Cl. Okay, this is what? Chloropropane, right? Chloropropane. This is an alkyl, right? Alkyl halide group, right? So benzene ring plus alkyl halide, that is chloropropane over here, in the presence of anhydrous AlCl3. Anhydrous AlCl3 came, means what process is this? Friedel Crafts alkylation. Why alkylation again? Because alkyl groups are getting joined to the benzene ring, right? So here we have three carbons, right? CH3, CH2, CH2. So these three will go and get joined here. So what I will have? I will have a benzene ring with CH group, and that CH group is attached to CH3, CH3. Okay, this is what is cumene. Okay, or it is cumene, or it is known as isopropyl, or it is known as what? Isopropyl benzene, right? This is isopropyl benzene. Yeah. So this isopropyl benzene or cumene, if I react it with O2, that is oxygen, right, it will give us what? See, we have two oxygens, right? So this propyl thing, everything will be the same. Okay, it will remain the same, and we'll just shift it that side, as you can see. Okay, I have just brought CH3 up and to the left side. Now what I'll do, this two oxygens, okay, they will come between this carbon and this hydrogen. Okay, so this will form COOH, and that C is attached to CH3 and CH3. This is cumene hydroperoxide. Okay, this is cumene hydroperoxide, and this one acidification, okay, and reaction with water will give us phenol. Phenol plus CH3COCH3, which is acetone. Okay, it will also give us acetone. Now this is a very important commercial method because of the byproduct, okay, which is acetone, right? Yeah. So now coming to the next one, that is from Grignard reagent. Okay, yeah, so when I come from Grignard reagent, again I have bromobenzene over here. Bromobenzene, first we'll create that Grignard reagent. Okay, we have bromobenzene plus magnesium in presence of dry ether creates my Grignard reagent, that is aryl magnesium bromide, right? So this is my Grignard reagent. Okay, reacting this with O2 in presence of dry ether will give me an O between this aryl group and this MgBr group. Okay, and then further reaction with H2O will give me phenol plus MgOH Okay, so yeah, with this we are done with the preparation of phenols as well. Now coming to the chemical properties of alcohols. Now we'll see their chemical properties. Yeah, so first coming to the acidic nature. Yeah, so when I come to chemical properties of alcohol in that acidic nature, so this alcohol on reaction with NaNH2 gives us RO minus Na plus. Okay, as we saw up. Okay, this is phenoxide ion, right? Sodium phenoxide, as we saw, right? where it went, yeah, so this was sodium phenoxide, right? So similarly we have like this ions, if we have alkyl groups as well, right? There we have, there in sodium phenoxide we had a benzene ring, right? Aryl group. But here we can add R as well, which is alkyl group, right? Plus NH3 we will get. Now this ROH on reaction with NaOH or NaHCO3, there is no reaction. Alcohols cannot react with NaOH and they cannot react with NaHCO3. Okay, but they can react with NaH, okay, to form RO minus Na plus H2, and they can also react with Na, okay, sodium metal in presence of heat, okay, RO minus Na plus half H2O. Next, coming to esterification, okay, alcohol on reaction with RCOOH, okay, carboxylic acid group, in presence of H2SO4, it will give us an ester. Okay, R C double bond O O R dash. Okay, so wherein R dash is the alkyl group present in my alcohol, right? Plus H2O. Now if this R dash OH reacts with R C double bond OCl group, okay, in presence of pyridine, then what happens? Then we will get again an ester, which is R C double bond OOR dash plus HCl. Now if it also reacts with this kind of compound, okay, which is RC double bond O on both the sides, RC double bond O, both are attached to a single O, both are attached to a single oxygen atom. So we will get an ester, which is RC double bond OOR, and a carboxylic acid, which is RC double bond OOH. Yeah, wherein you can see this is the R dash, okay, the alcohol wala alkyl group. Now coming to the third one, reaction with HX, that is halogen acids. So ROH plus HX, they give RX plus H2O, okay. Yeah. So, and reactivity of these HX is what? HI greater than HBr greater than HCl greater than HF. Okay. Now, reaction with PCl5, SOCl2, and PCl3, when we come about ROH on reaction with PCl5, it gives RCl plus HCl plus POCl3, right? And for SOCl2, when I talk about, it gives RCl plus HCl, okay, plus SO2. Now this is considered the best one because HCl and SO2 are both precipitates, okay, we directly get an alkyl halide over here, right? And 3 ROH on reaction with PCl3 giving 3 RCl plus 3 PO3. Further, if I talk about C2H5OH, okay, taking an example, plus 2HI, okay, 2HI, in the presence of red phosphorus, it will give me C2H6, okay, plus I2 plus H2O. Okay. Now coming to reaction with ammonia. What is ammonia? NH3. ROH plus NH3 in presence of Al2O3 and 360 degrees Celsius will give us RNH2 plus H2O. Oxidation. Okay. Primary alcohol on oxidation gives aldehyde. That further on oxidation gives us a carboxylic acid of same number of carbon atoms. Okay. Secondary alcohol. Okay, on oxidation they give ketones, and these ketones on oxidation give mixture of carboxylic acids with less number of carbon atoms. Tertiary, on oxidation with HNO3 they give alkenes, and again oxidation they further give ketones, which on further oxidation, of course, ketones will finally give carboxylic acid with less number of carbon atoms. Okay, now coming to the next one. Yeah, so here are the examples for those. Yeah, for example, if I say this is my CH3CH2OH, okay, primary alcohol. Primary alcohol on oxidation with K2Cr2O7 in presence of H plus will give CH3CHO aldehyde. Again, okay, on oxidation it will give CH3COOH, which is carboxylic acid. Then we have CH3COH CH3, okay, on oxidation with KMnO4 and H plus will give CH3 C double bond OCH3. This is the secondary alcohol giving ketone. Again on oxidation giving CH3COOH and HC, okay, HCOOH, okay, so it gives two carboxylic acids, okay, mixture of carboxylic acids, wherein this HCOOH, okay, it further oxidizes to become H2O and CO2. Then coming to tertiary ones, that is CH3 CCH3OH CH3. Okay, so here on oxidation with HNO3, as we studied, it will give me alkene. Okay, double bonded carbon, right? Alkene. This further non-oxidation will give me a ketone, CH3 C double bond O CH3. Okay, ketone. Now this further non-oxidation will give me CH3 COOH and H2O plus CO2, as we saw over here, right? Now coming to finally dehydration, okay, which is the seventh chemical property, which is CH2 CH2OH, okay, giving on the presence of H2SO4 and 383 Kelvin temperature, it will give CH3 CH2 HSO4 plus H2O, which is ethyl hydrogen sulfate, 383 Kelvin ethyl hydrogen sulfate, and 2 CH3 CH2OH, same H2SO4, 413 Kelvin. Okay, it is 413 Kelvin. Then it becomes CH3 CH2 OCH2CH3 ether, diethyl ether. It gives diethyl ether plus H2O, and this CH3 CH2OH in presence of H2SO4 at 443 Kelvin, it gives us an ethene, which is CH2 plus H2O. Now coming to the mechanism for the formation of that ethene. Okay, so the first step is formation of protonated alcohol, right? So this CH3 CH2OH plus H plus, okay, in the form of reversible reaction, it will give like this. Okay, hydrogen will go and attach to oxygen. So what will happen here? It has gone and reacted to oxygen. So formation of carbocation. Okay, this same product of previous will become the reactant of the next. Okay, so here we have CH3 CH2O plus. Okay, plus, super important, plus sign is very very important. H. Okay, reversible reaction. This plus sign, what it will do? What it will do over here is that now it will go and form H2O by breaking this bond. Okay, and it will take the lone pair of electrons with it, and now carbon will give off its electrons to oxygen, so carbon will have the positive charge, or simply easily oxygen will give its positive charge to carbon and form its independent water molecule by making a carbocation, which is CH3 CH2 plus. Okay, then coming to the removal of proton to get alkene. What do you mean by proton? Proton is hydrogen, right? So this is having plus, so I will remove this proton or remove this hydrogen, so that these two carbons can form a double bond. That's all. Then CH2 double bond CH2 plus H plus, what we gave came back, right? Yeah. So next, coming to catalytic dehydrogenation, is the same process, okay, but the only difference is copper at 573 Kelvin or 300 degrees Celsius has to be given over here instead of H2SO4. Again, primary alcohol in presence of Cu at 573 Kelvin will give us RCHO plus H2. Then R2CHOH, that is secondary alcohol, on presence of, in presence of Cu and 573 Kelvin will give R2CO plus H2. What is that R2CO? It's ketone. Then R3COH, presence of Cu and 573 Kelvin gives R2C double bond R. Okay, so instead of writing like this R, we better write such examples in the exam as well. Okay, yeah. So as we saw in the previous page, right? I'll just show you that once again, right? In this page over here that we saw, yeah, in this page for oxidation that we saw over here, primary alcohol, okay, gets converted to aldehyde, secondary to ketone, tertiary to alkene. That's the same concept that we are using in the next page for our catalytic dehydrogenation. Okay, yeah. So now coming to haloform reaction, CH3 CH2OH. Okay, our, this is what our alcoholic group, right? Plus 4x2, that is our halogen, right? Halogen molecule x2 plus 6NaOH will give CHX3 plus 5NaX plus 5H2O plus HCOONA. So it will give us a halo form CHX3. Now methanol cannot undergo this haloform reaction. Okay, it does not respond to this reaction. Now coming to chemical properties of phenol. Okay, when we come to chemical properties of phenol, they are pH O minus Na plus, okay, plus H2. Okay, yeah, so this phenol PHOH on reaction with NaOH, it gives pH O minus Na plus plus H2O. Okay, so sodium phenoxide ion, again on reaction with NaHCO3, again this can also not react with NaHCO3. Super important to remember with what phenol can react and with what alcohol can react, right? Now this phenol, again reaction with sodium, it can react, it will give sodium phenoxide plus half H2 molecule, right? Then we have the second called esterification. Okay, so phenol on reaction with RCOOH, it will give pH OCOR plus H2. Okay, on reaction with RCOCl and pyridine, it will give pH OCOR plus HCl. Then on reaction with RCO twice O, it will give pH OCOR plus ROOH, right? And this is an important one, again salicylic acid plus CH3CO twice O. Okay, reversible reaction, it will give acetyl salicylic acid or aspirin, super important, aspirin, right, plus CH3COOH. Direct question, that give a reaction for the formation of aspirin, right? So COOH and OCOCH3 is attached to the benzene ring. Okay, yeah. Then further coming to electrophilic substitution reactions, right? This phenol on reaction with 3Br2 in a polar solvent, right? Or bromine water in a polar solvent, we will get what? 2,4,6 tribromophenol. And Br2 in non-polar solvents, we will get orthobromophenol and parabromophenol, right? And next, coming to dilute HNO3, what will happen? We will get orthonitrophenol and paranitrophenol. Here, orthonitrophenol, it has intramolecular hydrogen bonding, while paranitrophenol, it has intermolecular hydrogen bonding. Okay, so intra means inside it, okay, and inter means from, okay, within two neighborings. Yeah, so these two are separated by steam distillation. Okay, reaction with concentrated H2SO4, right? Concentrated H2SO4, we will get what? This is phenol 2,4 disulfonic acid. 2,4 means what? O at ortho position and at para position. This on further reaction with concentrated HNO3, we get 2,4,6 trinitrophenol, which is also known as picric acid. Okay, give the formation or give a chemical equation, okay, reaction for the formation of picric acid. Direct question. Now why did we do, okay, why did we do so many things, okay, for the formation of picric acid? Because if I directly react this phenol with concentrated HNO3, I will get benzoquinone. Thus, phenol undergoes first sulfonation and then nitration to form this picric acid. Then coming to coal-based electrolysis, okay, these two super important. Okay, coal-based electrolysis. Now, here phenol undergoing, okay, reaction with NaOH gives sodium phenoxide, and reaction with first CO2 then H plus giving orthohydroxybenzoic acid, that is salicylic acid. Orthohydroxybenzoic acid. Okay. Now then coming to Remer-Timon reaction. Okay, phenol plus CHCl3, that is chloroform, plus aqueous NaOH, it will give us sodium phenoxide ion attached with this CHCl2, right? Okay, which is an unstable intermediate, as you can see, that's why in brackets. Then reacting with NaOH, okay, it will give us ONA, and here CH, instead of this Cl2 we will have two OH groups. Okay, so here what will happen? Removal of one H2O in presence of acid, we will get our salicylaldehyde. Okay, this is also very very important, which is salicylaldehyde. Okay, salicylaldehyde. Okay, salicylaldehyde. Yeah. Then coming to, so what does Remer-Tiemann reaction give us? It gives us salicylaldehyde, right? Then we have reaction with zinc dust, right? Reaction with zinc dust, phenol plus zinc gives us benzene. In presence of heat gives us benzene plus ZNO. Oxidation, phenol in presence of Na2Cr2O7 and H2SO4 gives benzoquinone, as we saw, right? Then on presence of CCl4 and OH minus, it will again give us what? See, salicylic acid. As simple as that. Okay. Then coming to our last topic called ethers. Okay. Preparation of ethers. Okay. We have two preparation methods. Firstly, by dehydration of alcohols. We have alcohols, and okay, firstly taking H2SO4, and at 443 Kelvin it will give us what? Alkene, right? Alcohol reaction with H2SO4 in 443 Kelvin will give us alkene. But if we take, okay, if we take 2 moles of this alcohol CH3CH2OH with H2SO4 at 413 Kelvin, it will give us C2H5O C2H5, which is an ether. Okay, next coming to Williamson's synthesis. So when we come to Williamson's synthesis, Rx, that is primary halide, okay, primary alkyl halide, it reacts with R dash ONA, yeah, which is the primary alkyl halide, as you can see, Rx plus R dash O minus Na plus. Okay, it gives us ROR dash plus NaX. Okay, it gives us ROR dash plus NaX. So here primary alkyl halide gives better results. Okay, if we take here primary alkyl halide, they give us better results. For tertiary alkyl halide, no ether is formed. If we take a tertiary alkyl halide over here, no ether is formed. Okay, instead an alkene is formed. So super important point, right? Then we have chemical reactions of ethers. So these are all what? Electrophilic substitution reactions, right? These. So the first one is what? ROR plus HX. Okay, reaction with what? Acid, right? HX, right? Halogen acid, which is, it gives us Rx plus ROH. Similarly, if I take an aryl group or a benzene ring, okay, in this same reaction, I will get phenol plus Rx. Okay, in this case, if I take a benzene ring, I'll get phenol plus Rx. Coming to halogenation, here anisole, okay, anisole, okay, which is a carbon, which is a benzene ring attached to OCH3. Okay, attached to OCH3, which is known as anisole. On reaction with Br2 in ethanoic acid, it will give us parabromoanisole and orthobromoanisole. Okay, nitration, okay, the this anisole again on reaction with H2SO4 and HNO3, it will give us orthonitroanisole and paranitroanisole. Okay, then we have Friedel-Crafts reactions, right? Acylation, alkylation. So here we have again our anisole plus CH3Cl in presence of anhydrous AlCl3, giving us here, okay, 2 methoxytoluene and 4 methoxytoluene. Okay, that is 4 methoxytoluene, this one, and 2 methoxytoluene. Okay, so as you can see, this is toluene, right? Benzene ring with CH3, right? And if I say benzene ring with CH3 here, if this is the first for it, second, third, okay, I'll take a thinner one. Yeah, this is third, and then this becomes fourth. So 4 methoxytoluene. Similarly here, if this is my first carbon for it, after this toluene, this methyl group, this is the first carbon, then this is the second. So 2 methoxytoluene. Okay, similarly this anisole, if it reacts with CH3COCl, okay, which is ethanoyl chloride. If it reacts with ethanoyl chloride in the presence of anhydrous AlCl3, we will get, okay, we will get acetophenone, methoxyacetophenone. We will get methoxyacetophenone. Yeah, of course, 2 methoxyacetophenone and 4 methoxyacetophenone, similarly as in this reaction. Okay, so with this, we are done with the chapter called Alcohols, Phenols, and Ethers. The notes will be attached in the Telegram channel. Okay, thank you.